Hi, everyone. It's been quite a long day, right? I understand that you may get tired after sitting here for hours, but trust me, if you pay attention to this 10-minute talk, you will definitely make your day fulfilling. This is simply because what I'm going to talk about next serves as a key element in Uber global expansion, which is from San Francisco to the world. Internalization, or i18n at Uber. Before we start, let me introduce a little bit about myself. My name is Yifan. After graduating from Duke University, I spent a year developing large-scale data center switches at Cisco in Miami. In 2015, I joined Uber and built many interesting pieces of software here, including communications big data pipeline, and centralized content authoring tool, and next-generation transition system. In my spare time, my interests span many aspects such as musical composition, interior design, investment, and business. My attitude towards life is simple: maximizing wealth while maintaining a comparatively high living standard and pursuing adventures with the guarantee of safety. I have a plan of retiring early, so if you share similar interests with me, please don't hesitate to reach out. Now, let's get back to our topic. As a preview, I will start with Uber global expansion. And next, I will explain how internalization fits into Uber ecosystem. And then I will dive into some details regarding how we improved the existing internalization process. Finally, I will close up this talk by sharing our next step with you. Now, let's start. When Uber went live for the first time in San Francisco, July 2010, we only support English. Now, we're supporting more than 50 languages in more than 600 cities around the world. By the year of 2018, 75% of trips takes place outside of the United States. What we can tell from these numbers is that Uber achieved significant success in its progress of globalization, and in return, the global market is bringing great influx of revenues to our company. At the same time, as we expand our business, we are facing fierce competition from many local businesses. These challenges encourage us to develop software in a way to enhance user loyalty by enabling a truly local Uber experience for users from all language backgrounds. So far, I talked about Uber global expansion. Now, let's turn our attention to this diagram and see how internalization fits into Uber globalization efforts. There are mainly two teams that directly contribute to Uber globalization: internalization team, or i18n team, and localization team, or i18n team. Internalization team is the engineering effort that enables the product to be localized. And localization team consists of project managers and language specialists. They are responsible to track and monitor the progress and quality of our transition tasks. We collaborate closely with each other, and together we are doing our best in enabling our products to be distributed globally. Let's cover why and how we build a better i18n system here at Uber. The first question is, why do we want to build a better i18n system? This is important because a better i18n system not only means greater user experience, but also more efficient engineering and localization process. When i18n is being done well, for Uber app users, they feel like Uber was designed and built just for them. For engineers, they can easily integrate translations with their features or product lines. For localization leads, the localization process will be much faster, of higher quality, and less expensive. So this whole picture seems really great, right? But how do we achieve our goals? Basically, we applied improvements in three main aspects: speed, accuracy, and cost efficiency. Let me elaborate further with examples. The first project contributing to transition speed improvement is our rapid transition service. You can see that our main transition service is using Git repositories for persistence and Uber deployment system for transition delivery. Therefore, it takes tens of minutes for a new transition key to get propagated. However, sometimes you want to see the transition process will happen much faster than usual. For example, city team need to send out some urgent communications to drivers, riders due to emergencies, events, weather, and etc. Another use case is that some products are very dynamic and are frequently updating data. To address above use cases, we develop a rapid transition service. It bypasses the existing transition delivery path by applying our non-SQL database with server and client-side data caching. So instead of 10 minutes for a new transition key to get propagated, our rapid version provides almost real-time updates. The second service that contributes to speed improvement is our mobile transition service. It serves as the backend for our dynamic mobile translation platform. It works as follows. First, it fetches transition updates from our rapid version, and then it stores the updates in database and Net3. Finally, the contents in Net3 are served to mobile devices via i18n. Previously, any mobile transition updates can only occur during mobile app releases. With our mobile transition service, any transition updates can be delivered to the end users within about an hour. Regarding transition accuracy improvement, we have ICU for Uber. ICU stands for International Components of Unicode, which is a set of libraries that provide Unicode support for applications. We develop a set of ICU libraries to serve Uber's specific use cases. These include accurate localization for dates, times, currencies, and numbers, and we support Go, Java, Python, and Node.js. The last aspect is cost efficiency. Currently, we are on a migration from the existing transition vendor to our new transition vendor. Once this migration is done, we'll be saving our company-wide transition cost by 5 times. And we built a microservice to bridge the communications between our main transition service and our transition vendor. Let me close on my talk by sharing our next step with you. As Uber is expanding itself worldwide, our i18n system is becoming scaled and complex that activities happen within the system are virtually impossible to track. We are working on building this trackable i18n system by leveraging the open source Elasticsearch technologies and our non-SQL database. With this new tracking system, one can easily use Google-like search to find any activities or updates within the system, and it only takes a second.